Okay, so this will be another video that will be going to tackle about the Ternary research. So in this case, we'll be going to step by step the process. I'll be going to introduce to you first the what is Ternary research all about, its definition, together with the what will be the Ternary research algorithm, how does it work then? So let's actually start. When we say Ternary research, that is definitely a divide and conquer algorithm, which is using or used to find an element in a sorted array, or more commonly to see the maximum or minimum of a unimodal function. So unlike binary search, which splits the array into two halves, ternary search divides it into three parts and recursively focuses on the relevant third, narrowing down the search space more aggressively. So in this case, in our previous discussion, we were able to have the binary search that you will be going to divide the following array into two halves. Say, for example, you were able to get the middle part of that. So in this case here, it would be somewhat similar to that one actually. However, in this case, you will be going to get a two midpoint, and there you have it. It will be divided into three categories, or I mean into three parts already. So in this case right now, it compares it to midpoints instead of just one typically used in data sorted. So it will also work in a sorted data already, or a sorted array. So we will begin to illustrate that in our example in the next video as well. So for ternary research, here then, this will be the steps that we will begin to consider with finding the two midpoints, compare the target element, and narrowing down the search range or repeat until the range is empty. So finding the two midpoints, dividing the array into three equal parts by calculating the two midpoints. So in this category, there will be a exactly as this kind of thing already then. So what you will begin to do with, in this case, you will begin to set a midpoint instead of only one midpoint. What you have to consider with is you will be going to calculate first the mid one and the mid two. However, you will be going to consider as well to check first, declare your category as well. I mean, in average step, since you will be going to calculate that one. It's not the same thing with a binary search. You will be going to calculate the low plus high and then directly be going to divide it into two. Then here, then this will be a calculation for the mid one as well as the mid two. However, the other we will begin to work in that as well. So for the mid one category, you will be going to calculate that one as here. We actually have the implementation is a mid one as equals to the low plus the high minus low, wherein this will be the category that we'll need to use with or base with that you were low, you have to add that into your what we call this one. You will begin to plus that into the division of the high minus low and then divide it into three as well. So since it will be basically divided into three parts as what we have mentioned, so that's why you will consider that accordingly. So in your mid two, it will be basically the mid two is equals to the high index and then minus the high minus low together with the division of the three as well. So that's what the things that you should consider in this calculation then. You will be going to step by step the process as always. So it will definitely matter in this one, and you will begin to it is basically nice because of course by doing that, so there will be a two array in one in one thing already. So let's actually proceed with here for the comparing the target element with arraignment one and arraignment two. This is the time that you will consider to maintain, or I mean, you will consider to what we call this one. You will check if the target is equals to the values of mid one or mid two, if and only if that your mid one is equals to the target. So you have to return the value, I mean the index number of that specific address. So if target is equals to that specific thing, so for the mid to solve the same implementation. So narrow down the search range. If target is equals to the array mid one, return mid one. If target is equals to the array mid two, return mid two as well. That's how we will deal with that here. So accordingly, next you have to narrow down the search range. If that is less than array mid one, so continue searching in the first, the third, low, mid one, minus one. So that is actually how does it work. If target array mid two, continue searching in the last third, mid two plus one, to high, else between mid one and mid two, search the middle third, mid plus one, to mid two minus one. So that's actually how it works here then, that you will be going to follow this kind of rules. If that your category and the if your target, if it is less than the value of your um array mid one, so you will be going to, if for example the target is 51, then your array mid one, if that is definitely less than the value of array mid one. So therefore you will continue to search in the left side, then that your mid one will basically um go, the your low will set to have a mid one minus one. That's how we will deal with that. So that we'll need to see that later on here. I know that it's actually in Vegas for now, but we'll begin to explain that step by step. So just a second. Let me fix here. A moment. Okay, so in this one as well, repeat until the range is empty. So you keep on dividing and narrowing the range until the target is found or the range becomes invalid. So in this case, for example, if you were able to check already, or if you're able to find that the target given that by you keep on dividing or conquering your data or the element, you should stop if you are not able to find that element. If you are able to find it already, that's the time that you will begin to return the value of that one specifically. So after that process, here then this will be the time complexity of this ternary search, that is a constant time for the best case. So that means to say that the target is found at one of the two midpoints in the first check. Excuse me. For example, if you're able to check or divide that one in the first check or the first implementation of yours, your algorithm, that you were able to find it that constantly. So that means to say that is a constant time, present time already. For the average case, it is definitely a logarithmic of n, because each iteration reduces the search space to 2 divided by 3, leading to logarithmic steps. So there will be a specific you're able to still find, and you divide that one, you still compare. So that's why it is definitely logarithmic of n. Now, time complexity for the worst case is still a logarithmic of n as well. Multiple splitting occur until the limit is found or the space becomes empty. So you're able to definitely it's not assured or that you were able you could be able to find that a given data. For example, if you could be if you will you were able to divide how many times, and you were not able to still search the specific element, so it will the worst case in your searching reports. Afterwards, the space complexity of this will matter in the recursive and the iterative thing as well. For this recursive, that is logarithmic eventually, the recursive calls stack depth, so it will be you're able to repeat and repeat the process then until you're able to find the base case. So in iterative, only fixed number of variables are used, no extra memory based on input size. So that's how we work here in the ternary research. So in order for us to really understand the method of this, I will be going to illustrate to you as well in another video the example how we could be able to work on with this ternary research, and see you in that next video then. Thank you.